Hello and welcome to the second lesson of Towle Tutoring. I'm Towle. Today we'll be discussing the square root of a squared plus b squared. Let me show you what this looks like. Now what most people will do when they see this is they'll see two numbers squared underneath the square root, and they'll say, oh, I know that squares and square roots cancel, so I'll just cancel them and I'll just get a plus b. This would be great if it was a squared times b squared or a squared divided by b squared, because squares and square roots distribute across multiplication and division, but they don't over addition and subtraction. It would be the same as saying a plus b in parentheses all squared is equal to a squared plus b squared. But we know from our math classes, hopefully, that when you get this, you have to FOIL it, because it's actually, when you expand it, it's actually a plus b times a plus b. So that would be a squared plus 2ab plus b squared. And these are different. This I know is right, because I expanded this. So this is wrong. And you probably shouldn't take my word for it, but let me try to prove it to you. And I'll prove it to you using triangles in the Pythagorean theorem. Now you know the Pythagorean theorem is a squared plus b squared equals c squared, all corresponding to the sides of a triangle. With c being the hypotenuse. Now, we know about a triangle that the sum of the two sides must be greater than the hypotenuse. So c must be less than a plus b. But if we use this method, if we use the method that is flawed in this, if we say, well, let me get rid of the square over the c, because we don't want that. We want it to solve for c. So we get c equals square root of a squared plus b squared. Now, if we use this method, the flawed method, we'll just cancel the squares and square roots. We get c is equal to a plus b. Now, the problem with that is because we know this, but we got this. That should tell us something. That should clue into our mind that maybe our method we're doing this is wrong. So, by doing it this way, you're basically saying one of two things. The Pythagorean theorem is wrong. We know it's right. Or, we can't have any triangles. And, well, I think if you talk to any engineer, I think at least they strongly believe triangles existed. So, yes, and that's all I have for you today. I hope to see you again in lesson 3. Until then, have a good day.